This is for you, Luke.
Yeah, Luke, what a guy.
All right, so this is section 5, and this looks like something. But if you didn't do section 4, this doesn't help you. But the idea is, actually section 4 is not really related. Section 1 is closer to section 5. Okay, section 1 is closer to section 5. Section 1 we did the antiderivative, right?
Oh, yeah.
Okay, so this is finding the antiderivative. The difference is the functions are more complicated. Now, they do mention the fact that there's a chain rule involved here. Okay, so this is the opposite of chain rule. All right, so looking at example 1A. Now, there are 2 ways to do these problems. Okay, the 2 ways is you look for a pattern or do a change of variables. They're kind of related. Okay, I want to do it with patterns to begin with, and then later on I will do a change of variables. And then and if you request it, I will go back to these again and do them with change of variables. Some people think fine for the pattern, but sometimes you have to change a variable because the pattern is not there. Sometimes you don't have a choice; you have to change the variable. All right. So now what you're looking at here is this a derivative of something? And here's what you do. So there's 2 functions. There's the 2x, and then there's the x squared plus 1 to the 4th power. And you look at yourself, is the derivative of the inside this? The answer is yes. Yeah?
Yeah.
So that means you have the result of chain rule. So when you integrate this, you're only going to do the power rule on the 4. So you add 1, divide by 5. And that's it. As long as you have the derivative of the inside, outside, you just do the other part. You don't have to worry about the 2x, because that's a result of chain rule.
So you take the derivative of the inside, and if it's the same as
What's on the outside, then you can just ignore the outside and just do whatever's left here.
I like that. Somewhat.
Well, it's nice when everything's there. It's just confusing when only pieces of it are there, or if it's not there at all.
All right.
Okay, let's look at B. So here, this looks like a composition, right? The square root of x cubed plus 1. So what's the derivative of x cubed plus 1? Oh, there it is. So that's it then, right? So just treat that like it's to the 1/2 power instead of square root. So that's going to be x cubed plus 1 to the, what is that, 3/2 divided by 3/2 plus c. And let's clean that up a little bit. So that's that. And then looking at C, that's the one you go, oh crap, what the heck is going on there?
Because trig.
So you go, look, okay, so you say C, there's secant and an exponent, and you go, what's the derivative of secant? Secant tangent. Well, that's not that. So what do you go, what the heck do you do? That's not a composition. But what's the derivative of tangent? Secant squared. So this is really screwy. And there's not even a power on it, but I'm going to use the power rule.
Yeah. Yeah, bring that one down.
So I'm going to say that's a power of 1 and do the power rule on that. Okay? So I add 1 to that exponent and divide by the exponent, right? But the derivative of tangent x is secant squared. So I can just ignore the secant squared. Plus c. So you're always looking for the derivative of something. Right? So I first looked at secant because that was the more complicated one. But it turned out it was the simpler one. The derivative of tangent was out here.
Makes sense.
This is the hardest one to see, though. I mean, this one's a toughie.
Yeah.
Okay? All right. Sometimes, as it says here, it's not a perfect match. Let's look at this one. What's the derivative of x squared plus 1?
2x.
I got an x, but not a 2. Those are easy to compensate for. Okay? So I'm going to just rewrite it so I have some space here. Okay, you don't have to rewrite it, but I'm going to rewrite it. I'm going to put a little space in there. So what I'm going to do, if I had a different, I don't have a different color pencil.
You're gonna put the 2 on the outside?
Ooh, alright. So I'm just going to put a 2 there. But if I put a 2 there, I have to compensate for that. I just changed the problem by multiplying by half on the outside. So I multiply the whole thing by 1. 1 is your favorite number because they can look like whatever you want. 1 is the chameleon of numbers. Because 2 over 2 is 1, right? So I multiply the whole thing by 1, which means I didn't change it.
I like that quote. 1 is the chameleon of numbers.
That should have been our senior quote. I'm 14. That's kind of deep.
Okay. So it's 1/2. So that's that 1/2. And since that is now the derivative of the inside, I can just use the power rule on that 6. So it's x squared plus 1 to the 7th power over 7 plus c. Clean that up, and it's 1/14 x squared plus 1 to the 7th plus c.
Okay. This doesn't suck. So far. Yet.
I feel like that's all about the change.
Give it time. Give it
Yeah.
time.
If there's always more when you think it's okay.
Is give it time referring to C?
No, c's not bad.
Okay.
It's 5.
Oh.
Okay.
Well, this one doesn't have 1 on the outside.
What's the derivative of 2x plus 1?
2.
2. Right?
So you do that same thing again?
Yeah. So let's do this. I'm going to rewrite it. And with a, exponent.
I have such a hard time drawing the integral sign.
Integral sign?
I make mine
I
more.
have no response to that.
It doesn't have to look like perfect, does it? Like on the actual AP exam? As long as you can sort of half tell what it is.
I don't know what perfect looks like for this.
That's a good point.
I mean, it's just an S, right?
Just a very long S.
Yeah. Just make the gut longer. Right? I mean, this is a regular S, right?
Just make it tall.
And by the way, if you made this as an integral sign, that's okay too. They're not going to complain about that. Because technically it is an S. It really is an S. It stands for sum. Okay, but they just wanted to make it look like a math symbol.
Wait, does that mean sigma's an S?
Yeah.
Okay. Huh.
Wait. Okay. Alright, anyways.
The more you know.
So the derivative of 2x plus 1 is 2. Compensate for that 2 by putting a half out there. Now you can integrate it using the power rule on that 1/2. On this 1/2. So it's 1/2. That's the same 1/2 there. 2x plus 1. Add 1 to the exponent, so it's 3/2 over 3/2 plus c. Clean that up, and we get what? 1/3? 2x plus 1 to the 3/2 plus c. Right. When you bring this out, that becomes 2/3, so 2's cancel, leaving with 3 in the denominator. All right. C. All right. Here's what I would do for C. First of all, what's the derivative of 4x cubed minus 5?
12x squared.
12x squared. That's a 7. So in my rewrite, I'm going to take the 7 out. Okay. And I'm also going to rewrite it. Let's see. X squared. And I'm going to put 4x cubed minus 5 to the negative 1/2.
Oh, that makes sense.
Okay.
Oh, alright. Wait, is the 7 on the bottom?
7 on the bottom? No, I just took it out. And then you said the derivative of this, derivative of 4x cubed minus 5 is 12x squared. So I'm missing the 12. So I'm going to put a 12 out here, and then compensate for the 12.
Ah,
So that's 7/12. And then use the power rule on that 4x cubed minus 5 to the negative 1/2. 4x cubed minus 5 to the positive 1/2 over 1/2 plus c. And if we clean that up, that becomes 7/6. 4x cubed minus 5 to the half plus c. You could rewrite a square root if you wanted to. I forgot. Okay. Before I go on, I was thinking I would do it the other way. Okay? So you can just watch. And if you want me to wait for you to copy it, I can do that, but you can just watch.
so do you mean like solving it through the substitution
No.
pattern?
Well, the way I'm doing this one is it's called pattern recognition. So yeah, this is called pattern. But there's another way to do this if you have a hard time seeing patterns. Okay? So you can just watch, and if you want me to wait for you to copy it, I can do that. But at the beginning, just watch.
Sure.
Okay? So all I'm doing is copying 2a. Right? So this is 2a. Alright. Oops. So when I write on blank paper, I write big enough that you don't need to see it. Alright, anyway. So here's what you do. So this is the technique. It's called U substitution. Now, pattern recognition is nice. It's less work. U substitution is a whole lot more work, but I think it's easier to understand. And eventually, you do still have to know how to do U substitution. There are some cases where you don't have a choice. Okay? So here's how you do U substitution. You know the complicated parts here, like the derivative x squared plus 1 is 2x. So you know that. So here's what you do. You let u equal that. Okay? And then you just take the derivative. du equals 2x. This is actually called the differential. Right? This is called a differential. You don't write du over dx. You put the dx over here. And then you look at what you got here. You got an x dx. Okay? Well, I have x dx. I don't have 2x dx. Solve this for x dx. So I'll divide by 2. So what I got is du over 2 equals x dx. Okay? And now you substitute. So I'm replacing the x dx with du over 2. I'm replacing the x squared plus 1 with u. So it's just u to the 6 du over 2. Clean that up a little bit. It says 1/2 u to the 6 du. So that's 1/2 u to the 7 over 7 plus c. 1/14 u to the 7 plus c.
And you just plug u in.
And you just plug it back in. So it's 1/14 x squared plus 1 to the 7 plus c.
So that actually seems simple. Huh.
Okay, so if you have a hard time identifying the patterns, this is another way. Some people never do it the pattern way. Nothing wrong with that. This is the more reliable technique. I'm just lazy. So whenever I'm doing a problem, I'm doing it the other way, if I can. But sometimes you can't do that. Okay. I'm going to jump to C. Some people are copying, that's why I'm waiting. Okay. All right, C. C is, so I'm rewriting it, but And again, the complicated part, that's why I'm going to do that U substitution. And that rule of thumb is pretty good, the complicated part. Let U equal the inside of the complicated part. So U equals 4x cubed minus 5. So du equals 12x squared dx.
So now I have to get it to equal 7x squared.
7x squared. Or, this is where it gets, take some liberties with it. Oh, no. There's a 7 there. It's in my way. Let's just move it out. Let's just move it outside. Okay, so now I just got to deal with it. Well, I got x squared dx now. So let's move to 12. So that means 1/12 du equals x squared dx. Yeah? As long as it's just a number, you can do that. Okay? Now, it turns out you can do it with other crap too. It doesn't have to be a number. But some math professors don't believe that. I don't know why they don't, but it works. I had a college professor tell me you can't do that. And then another college professor, what's wrong with that? So some people were just confused about this stuff. I went with the one who said you could. All right, ready? So this becomes, there's a 7 on the outside. X squared dx is 1/12. I'm going to put the 12 out there. So it's just du, right? So I'm replacing the x squared dx with du. I've already put the 12. Right, there's a 12. And then that's going to be u to the negative 1/2. Yeah? So that's 7/12 u to the positive half over 1/2. Let's see. Clean that up. 7/6 u to the half. Let's see. Of course, you don't have to take all these little steps.
And then plug u back.
Yep, you got to plug it back.
So why don't you plug in the du?
I did.
Yeah, I mean, why don't you substitute the du?
Say it again.
Why don't you substitute the du?
I did. I don't know what you mean. So I've replaced x squared dx with 1/12 du. So I did replace it.
But now you don't. But the x squared isn't in it.
Right, it got replaced with du. Right, this is what this means. What does that sign mean? It means the left-hand side is the same damn thing as the right-hand side. So that means the x squared dx can be entirely replaced by 1/12 du. So I've replaced x squared dx with 1/12 du.
Okay.
It's gone.
Okay, yeah.
Uh-huh. Well, I had a college professor who explained it that way. That's not an equal sign. That's the same damn thing sign.
Same damn thing, son.
I mean, if it works, it works.
All right. He cussed a lot during his lectures, though.
That's funny.
All right. Okay, moving on to the next one. All right. Oh gosh, I just cussed on video.
Got him.
Oh no. I'm too lazy to edit it too. All right.
Say goodbye to Schweitzer, guys.
Oh well. Okay. All right. Okay, so here, this is a composition of functions. Right? You got 2x instead of sine of 2x. So what's the derivative of 2x?
2.
2. So that means I'm missing the 2. Right? So I'm missing the 2.
The sign equal 2. Oh.
So compensate for the 2 I put there with half out there.
It says sin 2x still, right?
Yeah.
Okay, cool.
Looks like a plus. It looks like a V.
So what's the integral of sine?
negative cosine?
I think so, yeah.
Cosine's negative, sine, yeah.
So it's negative cosine 2x. If you did the U substitution way on that one, this would be U equals 2x. du equals 2 dx. So that would mean, well, 1/2 du equals dx. So you would do 1/2 du replaces the dx, so it's 1/2 du, and it would be sine of u. It would be 1/2 negative cosine u plus c, and 1/2 cosine of 2x plus c. So same idea. Okay. Can you integrate cosecant squared? Cotangent, negative cotangent. So that's going to be negative cotangent. Oh, that's this one here. Negative cotangent. So I got this theta over 4 in here. What's the derivative of theta over 4? 1/4. So I'm missing a 1/4. So I compensate for that 1/4 by putting a 4 outside. So I got 4 times 1/4 cosecant squared theta over 4. So I compensate for that. Now I need a derivative of theta over 4, put it here. Compensate for that 1/4 by putting a 4 out there. The integral of cosecant squared is negative cotan. So it's negative 4 cotan theta over 4. Let's see. Number 4, I'm going to do number 4, the change of variables way. Mostly because number 5, I have to do change of variables. Okay? And this is the most complicated one we've done so far. Number 4 is. How many functions do you see there?
3.
3. There's 3 functions, right?
Yeah.
That's why it's the most complicated. Up to this point, we've been doing with only 2 functions. This has 3 functions in there. All right. So then the question is, what is u? If I do u substitution, what is the u?
Cosine 3x?
Ooh. Okay. So whenever we do any kind of u substitution, you want to go for the most complicated. So cosine 3x, that's complicated, but sine squared 3x is more complicated. So I'm going to let u equal at least one level of that. So I'm going to let u equal sine 3x. And then du would be 3 sine, oops, no,
Sine
it's not.
squared?
3 cosine 3x dx.
U should be sine squared 3x, right?
No, you want u to equal the whole thing. You want u equal just a piece of it. Another thing, you could have said, well, why don't you let u equal 3x? Well, that doesn't help me deal with the sign. And if I let u equal sine 3x, the derivative of the inside is not too bad, right? The derivative of sine 3x, derivative of 3x is 3, so I'm only missing the 3. Right? I have this cosine 3x there, I'm only missing the 3. So that means du over 3 equals cosine 3x dx. Now let's do the substitution. So that's going to be, so sine 3x, I'm letting sine 3x squared, so that's u squared. And cosine 3x dx is du over 3. So that's du over 3. All right, let's clean that up a little bit. So it's 1/3. I just go ahead and bring, whenever I have numbers, and if I can't pull them out, I just pull them out. All right. d over 3 is the same as 1/3. So it's 1/3 u squared du. Now we integrate that. So it's u to the 3 over 3 plus c. Clean it up one more time before we substitute. So it's 1/9 u cubed plus c. What was u? U was sine 3x. And u was sine 3x. So sine 3x to the third. Don't forget, if there's a multiple choice question, they're probably not going to write it like that. They're probably going to write it like this, sine cubed 3x plus c.
Always confuses me having a cubed on the side instead of the whole thing.
I agree. It's a lousy notation.
We should just change math.
The math doesn't need to be changed. It's the notation that needs to be changed. Like, I don't like the equal sign.
You mean the same damn thing, sign?
Yeah.
thought
I
you-
prefer the computer version of it, right? Computer version, you use two of them to mean equal.
Huh.
I take that back. You use two of them, just ask if they're equal. You use one of them for assignment. Anyway, I'm talking stupid stuff. All right, let's go on to this one. So same idea, and you do this when you look at this and go, "Oh, that just really sucks." Look at this. What's the derivative of 2x minus 1?
2.
2, not x. There's no x in the derivative of 2x minus 1. And then he goes, so then what do you change the variable? Can you do u equals x? Doing u equals x is pointless, right? You got to make u equal to something more complicated than that. So then what? Do you do u equals 2x minus 1? Well, let's give that a shot. U equals 2x minus 1. So what is du?
2.
2 dx. And then you go, well, what do I do with that x? Write it in terms of u. So you have this equation. Solve that for x. So that would be u plus 1 over 2 equals x. Right? You add 1 to both sides. That's where the u plus 1 comes from. Divide by 2 gives you the u plus 1 over 2. Okay? And let's go ahead and make this d over 2, right? d over 2 equals dx. So let's do that substitution. So this becomes, so I'm replacing the x
With u
plus 1 over 2, yeah. So u plus 1 over 2, and square root of u, and dx is du over 2. Remember, these are like parentheses, I guess. All right, there's a half, and there's another half, so let's bring that out. Let's make it a quarter. And that's u plus 1 times the square root of u. And then you go, Mr. Wright, that's not any better. It looks almost the same. Well, this actually cleans up nicely. Because here, I could not do anything to clean that up. I can't like multiply that out. But here, I can multiply that out. I can do u times square root of u. I can distribute that. So that's going to be u to the 3 halves plus u to the half. Right? Remember, square root of u is the same as u to the half. U to the half times u is u to the 3 halves. 1 plus a half is 3 halves. Now you integrate it. Just power rule. I'm going to go ahead and put that in square brackets there. So u to the half, u to the 3 halves, add 1, that's 5 halves. So it's 2/5 u to the 5 halves plus, what's that? 3 halves, so it'll be 2/3 u to the 3 halves. Plus c. Clean that up. So distribute the 1/4, and let's replace the u with 2x minus 1. So that's going to be what? 2 times 5 is 10, so it's 1/10 2x minus 1 to the 5 halves, 1/6 2x minus 1 to the 3 halves, plus c.
Now it sucks.
Now what?
So now this sucks.
Yeah. So, really, my goal for this one is to turn the radical into a monomial. Right? Then I can distribute that thing. The square root of 2x minus 1, that's the problem. X outside is not that big of a problem. So when I look at b, I want to let u equal x plus 4, so I can make that a monomial. Right? Because then you can just do whatever you want with a monomial. Okay? So that x plus 4, I'm going to just let u equal that and get rid of that variable entirely. And I know I'm not going to have enough space here, so I'm going to flip this paper over. Okay, how are we doing on time?
About
10 minutes.
Okay.
Yeah.
All right, ready? I'm doing b.
That's something.
So you want to write it as one big thing?
Oh, hold on. Let me copy it first. Okay. So, I want to replace the x plus 4 with u. If you want to go ahead and solve this for x, you can make it u minus 4 equals x. What is du?
Du is dx.
Dx. Oh, that was simple. Nothing fancy there. Alright, so now let's do the substituting. So integral, I'm replacing the x with u minus 4. So it's 2 times u minus 4 plus 1 over square root of u. And dx is being replaced with du. That's a u. Oh. Alright, let's clean that up. So that's going to be 2u minus 8 plus 1 over u to the half. So all I'm doing right now is just regular algebra. 2u minus 7 over u to the half. And then clean up even more, right? I don't have a quotient rule for integration. So go ahead and just divide that out. So that's 2u to the half minus 7u to the negative half. Right? All I did was go into each one individually. So u over u to the half is u to the half. 7 over u to the half is 7u to the negative half. Now when we integrate that, so that's going to be 2u to the, I went to the exponent, so it's 3 halves over 3 halves minus 7u to the positive half over 1 half plus c. Let's clean that up. So that's going to, I'm going to bring the 2, if I bring the 2/3 up, that's going to be 4/3. 4/3. Replace the u with x plus 4. It's going to be 14. X plus 4 to the 1/2. Let's see.
That's 4/3, right?
Yeah. What are we doing on time now?
You got about
5
6
minutes.
5? Do one more. Ready?
So that's the final answer?
Yep, final answer. Okay. 6A. Now, you are expected to be able to do this on the AP test. Okay, the whole change of variables thing. So I'm just going to go through it. But the difference here is this is a definite integral. I got numbers on there. And that's going to actually change things. So u equals x squared plus 1, so du equals 2x dx. I have x dx, so I'm going to solve for x dx, so it's 1/2 du equals x dx. Now, these numbers are x equals 0 to x equals 1, not u, so you can't put 0 and 1. If you change variables, you can't put 0 and 1. You can put x equals 0, x equals 1, and put your u's in here. But let's take it further. If x equals 0, what is u?
1?
1. So I'm just going to want to change it to 1. If x equals 1, what is u?
1.
Try again.
2.
2. Okay?
That's not always going to be the case?
What do you mean?
I assume that's, are you always just going to plug it in?
Yeah. Okay. All right. Now, go ahead and do my substitution. The x dx is 1/2 du. So I'm going to put the 1/2 out there, put the du over here. And u cubed. Now, this is what AP expects you to be able to do. Right there. Be able to rewrite that given a certain substitution. That's what they're expecting you to do. They don't care if you take it further. Well, taking it further is easy, right? That was the hard part. Changing the variables is the hard part. That's what they expect you to be able to do. Now let's just finish that off because I don't like leaving it alone. Right, so you just change, so it's u to the 4th over 4, taking from 1 to 2. So that's 1/8. Plug in 2 to the 4th minus 1 to the 4th. What is that? What's 2 to the 4th? 16. So that's 15. 15/8. Notice I didn't change it back to x. If you've changed the limits, you don't need to go back to x.
But why is it minus 1 to 4?
This is where section 4 counts. If you, what you do is you plug in the 2, minus plug in the 1.
Okay.
That was section 4. Or maybe section 3 and 4. I forget which section. And we'll stop there for today.